Hi everyone, today's our topic is genai. Foundation of generative AI. What is genai? Genai refers AI system. AI means artificial intelligence system that can generate new content. Content means any type of data like text, image, code, audio, video that resembles human created content, जो human created content की तरह लगे. Unlike deterministic model that classify or predict, generative models learn the underlying distribution of training data and create new samples from it. So like previously what we have in data where we are classifying the data, okay, but now these generative models learn from the data and based on their training they create the new samples from it. Now the key difference between traditional ML versus GenAI. Traditional ML versus generative AI goals. Goals, it is here we are classifying or predicting. Here we have text, image or code and audio. Output, labels, number, output, text, image, code and audio. Examples, spam filter, price prediction. And here examples are ChatGPT, DALL-E, stable and diffusion. Data needed, labeled data set, large unlabeled data corpus. Training, here models are trained on supervised and unsupervised. Here we have self-supervised and RLHF. Now the most important topic, LLM. L stand for large, second L language model, large language model. Okay, so LLMs are the deep learning model trained on massive text corpora that generate text by predicting the next token based on context using the transformer architecture. So LLM are the deep learning model trained on massive text. It means here name itself defines meaning that the models that are trained on large data, means massive text, that generate text by predicting the next token. Okay, so how LLM work? It will predict the next token based on the context using in the transformer architecture. Now in next part of this video we'll cover the transformer architecture. So in basic terms how LLM works, let me tell you step by step. So first, text is broken into tokens. Like we can assume one token is about 4 characters. Okay, tokens are converted to be embeddings, numerical vectors like 0.1, 0.2. Suppose we have a word bed. So bed has 3 characters, right? Okay, so it will be considered as one token, and for bed we will given as 0.4, and later on beds is 0.5 something. We will give each word a numerical vector. Transformer encoder decoder process using attention mechanism. So transformer, how transformer work? It will work on the attention mechanism. Okay, now model predict probability distribution over next token. Token is a sample based on the temperature, top P settings. Process repeat until completion or max token reach. So this is how LLM work. Let me explain you in small way. Like when we have a word, so that word will be means word in the sense, suppose we have a sentence called my name is puppy. So puppy is a name. Okay, so my is a word, one token, name is a one token, is one token, puppy is one token. So now for each token for in LLMs we will convert into embeddings, and that embeddings then further use for the attention mechanism. Here model will predict next token. Suppose similar comes like puppy eat chicken. So puppy eats chicken, maybe that chicken will come how? In previously, suppose we have stored chickens are mostly eaten by puppies. So now it's embedding and my name is puppy. So next word will be chicken. It based on the embeddings and based on some calculation, we will further read about that how we will calculate the next token, but how it works, it will basically predict the next token. Okay, we'll cover it separately. So this is the steps that you must know. Okay, now critical LLM terminology. Term definition. Tokens. Tokens are the basic unit of text. Context window. Max token model can process at once. Temperature. Control randomness, like 0 is deterministic and 1 is creative. Okay, so these are some important critical terminology. Next is top P. Sample from top P % probability mass used with